Okay, so there we go. All right, so we started our notes and I forgot to record, so we'll go back through this super quick. Jesse and Riley better watch the video. All right, so we're solving this equation in which the variable that we're solving for is in the exponent, so we took the natural log of both sides since we could do anything to an equation, including take the natural log of both sides. That enabled us to bring that exponent down in front as a coefficient using that power property. The natural log of e is 1. So where I see this natural log of e, that becomes 1. To get rid of the negative 0.04, we divide, but of course we have to divide on both sides. Then I went to my calculator, and I got this. Did y'all get the same thing? Okay, 74.89. Okay. If natural log exists for only positive numbers, the domain will be 0 to infinity. Okay, so why does this exist for only positive numbers? Okay, natural log of x. Remember, there's this understood base of e, and equals, I don't know, some number over here. Okay? All right, so let's think about this. If I am changing this to exponential form, then this would be e to a number equals x. Okay, well, e is this number like 2.72 raised to the x is what I'm looking at there, or raised to a number. Can I raise a positive number to a power and get anything but positive? Like, I'm not going to take almost 3, raise it to a power, and get a negative answer, right? So that's why the domain is from 0 to infinity. So when you have a logarithm, I'm going to call this the argument here. The argument has to be positive. Notice there's not a bracket on 0. Okay, 0 is not positive. 0 is neutral. So when I say that this domain has to be positive, it cannot be 0 and it cannot be negative. It has to be greater than 0. Okay, so now we're going to talk about the derivative. For any positive number x, the derivative of natural log x is 1 over x. Derivative of natural log x is 1 over x. So if I wanted to find the derivative of 5 natural log x, do I need to use the product rule? No. 5 is just a coefficient. Now, I would absolutely have to use the product rule if it was 5x natural log x. So 5 does not have a function of x, it's just a coefficient. Okay, so what do we do with coefficients? We bring them down with it. So this derivative here would be 5, and then times the derivative of natural log. The derivative of natural log is 1 over x. So it would be 5 times 1 over x. Okay, how else can I write 5 times 1 over x? 5 over x. Okay, this next problem, I do need to use the product rule. Why is that? Function of x times function of x. Only in this first term. So here's a function of x times another function of x. This is a product rule term. So think of this as u, and that's v. And my derivative would be u times v prime. Derivative of natural log x is 1 over x. Plus u prime 3x squared times v, natural log x, plus derivative of 4x is just 4. Okay, so u v prime plus u prime v, and then I moved on to the next and last term. Okay, now these often can be simplified, because how else can I write x cubed over x? I just told you. I could write that as x cubed over x. Plus 3x squared natural log x plus 4. But what does x cubed over x reduce to? X squared. So I would do that reducing, leave that as x squared, and all of that would be my derivative. Question? Okay, what am I going to use on part C? Quotient rule. All right, here we go. Low, d high, derivative of natural log is 1 over x, minus high, d low, which is 2x, over the square of what's below. Okay, what does x squared times 1 over x become? X squared over x, which is x. So you can even think about it back here, like that's technically over 1. So that x is going to reduce with one of those. So that whole little product there is just x. Minus, I'm going to put this 2x in front of the natural log x. Does anybody want to guess why I prefer to do it that way? I'm going to write it as kind of like a coefficient because I don't want you to make the mistake to make that a 2x squared. Okay, that 2x has nothing to do with the natural log. It's not part of the natural log. So either leave it in parentheses to show me that it's separate, or what I will usually do is just put it out in front so we don't make a mistake and multiply those. Okay, even if you mess this up and add them instead of multiplying them, you're going to get x to the 4. Technically, we're multiplying those exponents. Question. Can I simplify?
Yes.
I can. Why?
You can take it next time.
Absolutely. So does that become 0? 1. Very nice. 1 minus 2 natural log x. Now, the x doesn't come out of this because it's part of the natural log. We're only dividing the coefficient there, and that becomes x cubed. Very nice. Question? All right, one more derivative. You know we can't leave out the chain rule, right? Okay, so this is when we have the natural log of a function of x. Wait a minute, wasn't this a function of x? Yes, because it was x. But what is the derivative of x? 1. Okay, so technically back here we were using the chain rule, but the derivative of x is just 1, so we basically ignore it. But if this function has a derivative that's not 1, then we have to take that derivative and multiply it. That's what we call the chain rule. Okay, so what we're going to do is, when we take the derivative of natural log of something, we are still going to put 1 over that something, but then we have to remember to check the derivative of the something. And that's our chain rule. Okay, so let's look at some real variables and numbers here. For example, natural log of 3x. Okay, so I told you derivative of natural log is 1 over x. Okay, this is my function. It's going to be 1 over that function, but then I have to multiply by the derivative of the 3x. Okay, so my derivative is 1 over 3x. Whatever you're taking the natural log of, derivative is 1 over that. But then I have to remember to take the derivative of that function, which in this case is just 3. Now that becomes 3 over 3x. These can usually be reduced. And then that reduces to become 1 over x. Question? All right, let's look at the next one. Anytime I see natural log, first thing I'm going to do is say, okay, derivative is 1 over that. So 1 over that whole thing that I took the natural log of. But then check that function, does it have a derivative of its own? Yes, that derivative is 2x. Okay, so then I can combine those into 2x over x squared minus 5. Do those x's reduce? No, because this term does not have an x in it. So in this case, not reducible. Stays as is. I had a question for you. I'm glad you came by. Let me do this one more and then I'll ask you.
What is this class?
Calculus.
Oh,
And we are missing a couple today who decided that they weren't going to join us.
yeah.
Okay, f prime of x. Anytime I see a natural log, the derivative is 1 over this thing. So I have 1 over natural log of x. But chain rule tells me, hey, don't forget to take the derivative of this. Well, what's the derivative of natural log x? 1 over x.
Wow.
So it's a little confusing. And then I don't make this x squared. This is natural log of x, not just x. So like I did before, I'm going to write this as x natural log x, so that I don't make the mistake of trying to multiply those x's and make them x squared.
If we were to make that mistake in the test, is it just completely wrong or half credit?
Yeah, you would probably get about half credit for setting this part up right. Okay. All right, so try these three using those above as examples. And then I think that's, oh, we have one more. Okay. Try those three for me. Did Mr. Merson die?
Yes.
Okay, I wonder, because, you know, that Robert Kinnemer on Maple Street, how he always put stuff on his sign. It had something
That
about
was a couple or 3
how,
weeks ago.
okay, it had something about how Lee or something from the community or something.
I said the Christian Yale.
So he worked till the day he died.
Yeah.
I think, I'm not sure what he had. I think he had cancer of some kind. Because in the obituary, the children mentioned the care, I don't know if they specifically said hospice care. Thank you for the.
Okay, let's back this up. Okay, so part A was 1 over x. Part B should be 6x over 3x squared plus 4. And then part C is the tricky one. So we see natural log of stuff in parentheses. Derivative is 1 over stuff in parentheses. But then I have to take the derivative of the parentheses. Well, it's a natural log. So then that derivative is 1 over 5x. But then 5x has a derivative, which is 5. So what ends up happening is these two 5's will cancel, and I just have the natural log of 5x and an extra x on the bottom, and so I put that out front so that we don't make that 5x squared. Question? Are we cutting grass today out there? Is that what I'm hearing? Oh, so y'all get to watch every time he walks by. Okay, in a psychological experiment, students, hey guys, last example, you know what you need to do.
Alright, we got it.
In a psychological experiment, students were shown a set of nonsense syllables, such as P-O-K, R-I-Z, D-Q, and so on, and asked to recall them every second thereafter. The percentage RX who retained the syllables after 10 seconds was found to be given by the log learning model, R of T. What percentage of students retained the syllables after 1 second? What would I do? Let's go back and read this part. The percentage R of X who retained the syllables after T seconds. So T is seconds. If I want a percentage, then that's what R of X represents. So if I want the percentage after 1 second, what do I do? Plug in 1. That's it. Okay, let's talk about what natural log of 1 is for a second. If I had base E, and I raise E to a power to get 1, E to what power equals 1?
Easy 0.
To the 0. Okay, so you can type that in your calculator, or hopefully, we'll start to see, oh yeah, that's just 0. So if this is 0, and it's multiplied by 27, then that whole thing is 0. And I should just get 80. Now, what would my answer be? 80 what? $80? 80 feet? 80%. Okay, so what this means is, if you were shown a set of crazy little mini words like this, that really weren't words, and 1 second later I asked you to recall those, you would remember 80%, or in this particular study. Okay, what do you think it'd be after about 10 seconds? Lower. After a minute, you'd probably be like, I don't know, I remember one of them, maybe? Okay, part B. Find R prime of 2 and explain what it represents. What would R prime in general represent?
The change in percent.
Yeah, the rate that that percent is changing. And we would expect it to be a negative, right? Because your percent that you remember would be decreasing. Okay, so at 2 would mean what? 2 seconds later, what is the rate that you are retaining these words? Okay, so the rate of percentage retained after 2 seconds. And then as time went on, I would expect that rate to decrease even more. Okay, so let's find it now. So let's find R prime of t. Derivative of 80 is 0. Derivative of negative 27 natural log t would be what?
27.
Okay, negative 27, keep the negative with it. And then derivative of natural log t is 1 over t. And don't have to worry about chain rule because derivative of t is just 1. So really it's just negative 27 over t. But now I want to evaluate that after 2 seconds. So that will be negative 27 over 2. Okay, as a decimal, what is that? Negative 13.5%. So that means for every second, we're losing 13.5% of those words we remember. That's a pretty fast rate. Question. Okay, now we'll work on the homework. So we have about 35 minutes. And, do y'all want to just start on these, or do you want me to work some with you?
You can start off this.
Just try them? Okay, let's do it. If you did not do these 1 through 24, you need to add those on to it, for sure. Okay? If you finish today, you may turn it in, but I will officially collect it on Monday when we come back. Okay? All right.